There is a fundamental threshold in mechanical physics known as the ultimate tensile strength. It dictates the exact mathematical point where a structure stops bending and violently snaps. A suspension bridge made of hardened steel, a titanium tether holding a satellite in orbit, even the microscopic chemical bonds anchoring the carbon atoms inside your own bones. Everything has a breaking point. Every physical structure can only endure so much outward force before its internal binding energy fails. For over a century, astrophysicists operated under the comforting assumption that this strict rule applied only to the localized matter within the universe, and not to the foundational fabric of the universe itself. The data says otherwise. In the year 1998, a singular, terrifying anomaly emerged from the light of dying stars. Teams of researchers were observing distant supernovas, mapping the exact rate at which the cosmos was slowing down after the primordial fires of its birth. We expected to measure a gradual, predictable deceleration. Instead, the instruments revealed an absolute physical impossibility. The expansion of reality was not slowing down. It was accelerating. An invisible, pervasive pressure was actively stretching the geometry of empty space. We named this unseen force dark energy. For decades, the standard cosmological model treated it as a simple constant, a cold, steady stretching that would eventually leave the universe as an empty, freezing void over the span of trillions of years. It was a bleak fate, but a peaceful one, a slow fading of the light. But the newest data, gathered from the deep field observations of our most powerful orbital observatories, has fundamentally broken that standard model. The expansion rate is not holding steady. The tension is compounding. The void is growing stronger, more aggressive, multiplying its outward force with every passing millennium. The cosmic scale factor, the mathematical metric that dictates the physical distance between all points in spaces, rising on an exponential curve. We are not just drifting apart into a quiet night. We are racing toward a catastrophic mechanical failure of space-time, a specific, calculable moment when the outward pressure will overwhelm every fundamental force in nature. Gravity, electromagnetism, the strong nuclear force, all of them will eventually be overpowered by the vacuum itself. This is no longer a fringe hypothesis or a simple philosophical abstraction. It is a measurable, physical certainty hiding inside the most recent variations of the Hubble constant. The machinery of the cosmos is tearing itself apart, faster than we ever calculated. If you seek to understand the grim mechanics of reality and the exact mathematical fate waiting for us in the dark, subscribe and join us on this journey. To truly understand the catastrophe that is unfolding in the darkness above our heads, we must first confront a harsh biological reality. Your brain is a liar. The human mind did not evolve to comprehend the architecture of the cosmos. It evolved to calculate the trajectory of a thrown spear, to anticipate the fall of a heavy rock, to navigate the rigid, localized physics of the African savanna. We are deeply, permanently wired to believe that what goes up must eventually come down. We are programmed to trust that an object in motion will face resistance, that a fire will run out of fuel, and that the physical structures around us are inherently stable. We apply this localized, primate intuition to the entire universe. For thousands of years, our ancestors stood in the cold night, looked up at the glittering canopy, and saw a static dome, a permanent, unchanging ceiling. The stars were viewed as fixed points of light, pinned to a celestial sphere, rotating with the precision of the gears inside a grand clock. It was a comforting illusion, a safe, predictable framework that made us feel secure in our tiny, fragile existence. Even as our technology advanced, that desperate human desire for a stable reality infected the highest levels of scientific thought. In the late 17th century, Sir Isaac Newton formulated his laws of universal gravitation. He gave us the mathematics to understand how planets orbit stars, but he still envisioned space as an empty, passive stage, a quiet, inert theater where the actors moved, but the stage itself never shifted. Then came the year 1915. Albert Einstein published the general theory of relativity, completely destroying the Newtonian concept of an empty stage. Einstein proved that space and time are physically woven together into a flexible, dynamic fabric. Space-time could bend. It could warp under the immense weight of stars and galaxies. It was a revolutionary leap in human understanding. But Einstein, even with his unparalleled genius, was still trapped by human intuition. When he looked at his pristine, elegant equations, he realized they predicted a terrifying instability. If gravity was a universal attractive force, then the combined mass of every star and galaxy should be pulling everything inward. His math clearly stated that the universe could not sit still. It either had to be expanding outward from an initial state, or it had to be collapsing inward under its own crushing weight. Einstein found the idea of a dynamic, shifting cosmos deeply unsettling. It violated his philosophical belief in a permanent, eternal universe. So, he altered his masterpiece. He deliberately introduced a mathematical patch into his equations to stop the universe from moving. He called it the cosmological constant. It was a hypothetical, outward-pushing force designed to exactly, perfectly balance the inward pull of gravity. He engineered his math to force the cosmos to hold its breath, to remain a safe, static clockwork. It was a beautiful attempt to tame the dark, and it was absolutely wrong. The illusion of stillness was finally violently shattered in the year 1929, in the freezing temperatures of the Mount Wilson Observatory in California. Astronomers were peering through massive glass lenses, staring deep into the abyss. Using the meticulous foundational work of Henrietta Swan Leavitt, who had discovered a way to measure extreme cosmic distances using pulsating stars called Kiffid variables, a scientist named Edwin Hubble began mapping the distant islands of light, galaxies residing millions of light-years away from our own Milky Way. What Edwin Hubble saw through that telescope fundamentally rewrote the human condition. He was analyzing the light spectrum emitted by these distant galaxies, and he noticed a consistent, undeniable anomaly. The light was stretched. Imagine standing on a quiet street at dawn. An ambulance drives past you with its sirens blaring. As it approaches, the sound waves are compressed, and the pitch of the siren sounds higher. But the exact moment the ambulance passes you and speeds away, the sound waves are stretched out. The pitch drops. It becomes a lower, deeper wail. This is the Doppler effect. Hubble realized that the exact same phenomenon was happening to the light of distant galaxies. Because they were moving away from us, the wavelengths of the photons they emitted were being stretched toward the red end of the electromagnetic spectrum. It was a cosmic redshift, and the further away a galaxy was, the more intensely its light was shifted. The galaxies were not just drifting through space. The foundational fabric of space itself was expanding. Like a loaf of bread rising in an oven, carrying the raisins along with it. The universe was swelling outward in every conceivable direction. We were living in the aftermath of a primordial detonation. The entire cosmos was flying apart. Einstein would later call his static universe patch his greatest blunder. The scientific community accepted the new, dynamic reality. But even then, humanity clung to one final, comforting assumption. We replaced the illusion of a static universe with a new, equally false sense of security: the absolute supremacy of gravity. For the next 70 years, astrophysicists operated under a very logical, intuitive consensus. Yes, the universe is expanding, born from an unfathomably violent explosion, but that expansion must be slowing down. Think back to the biological intuition of the thrown stone. If you hurl a stone straight up into the sky, it moves fast at first, but immediately the invisible tether of the Earth's gravity grabs hold of it. You can see the stone lose momentum. You can watch the kinetic energy bleed away as gravity fights it. Eventually, one of two things must happen. Either the stone runs out of speed, stops in midair, and plummets back to the ground, or, if you somehow threw it with enough explosive force to escape the atmosphere entirely, it will coast into the void. But even as it escapes, the Earth's gravity will still pull on it, constantly dragging on its heels, ensuring its speed decreases for all of eternity. Astrophysicists applied this exact same logic to the entire expanding universe. They looked at the hundreds of billions of galaxies, the supermassive black holes, the infinite clouds of heavy cosmic dust, and the invisible scaffolds of dark matter that weave through the void. They calculated the combined gravitational mass of all creation, and they concluded that this immense collective gravity must be acting as a universal brake on the expansion of space-time. The scientific debate of the late 20th century was not about whether the universe was slowing down. That was considered a settled, irrefutable fact. The only debate was about how much it was slowing down. There were two leading hypotheses. The first was the Big Crunch. This theory proposed that there was enough mass in the universe to eventually halt the expansion completely. Trillions of years from now, the cosmic brake would lock. The expansion would stop. The galaxies would hang motionless in the void for a split second, and then the terrifying inward collapse would begin. Everything would rush back together, crushing the cosmos into an infinitely dense, infinitely hot point, essentially reversing the birth of the universe. The second hypothesis was known as the Big Chill. This theory suggested that the initial explosive force of creation was just a little bit stronger than the total gravity of the cosmos. The universe would expand forever, but it would constantly, perpetually slow down. The galaxies would drift further apart, but their outward velocity would decrease every single day, asymptotically approaching zero. A slow, gentle fading into a freezing darkness. Both scenarios were grim, but they were rational. They obeyed the laws of thermodynamics. They made sense to the human mind. The physical universe was engaged in a grand cosmic tug of war between the outward momentum of the initial expansion and the inward drag of gravity. And gravity was expected to dictate the final terms of our reality. But as the 20th century came to a close, a new generation of observational technology was brought online. The National Aeronautics and Space Administration launched a magnificent orbital observatory into the vacuum above our atmosphere, free from the blurring distortion of the Earth's air. The Hubble Space Telescope stared into the deepest, darkest, most empty patches of the night sky. It stared for weeks at a time, patiently collecting ancient photons that had traveled for billions of years across the expanding void. Simultaneously, international teams of astronomers on the ground began hunting for a very specific type of stellar explosion, a Type 1a supernova. When a white dwarf star, the incredibly dense, dead core of an ancient sun, feeds like a parasite on a companion star, it pulls massive amounts of stellar gas onto its surface. Eventually, the dead star reaches a strict mathematical weight limit, a critical mass threshold where its internal atomic structure can no longer support the crushing pressure. In a fraction of a second, the entire star detonates in a thermonuclear explosion so violently bright that it outshines its entire host galaxy. Because these specific explosions always occur at the exact same critical mass, they always emit the exact same peak luminosity. They are standard candles, beacons of absolute, measurable light. By calculating how bright the explosion appears from Earth and comparing it to its known, true brightness, astronomers can measure exactly how far away the galaxy is. And by measuring how severely the light of that explosion has been redshifted, they can determine exactly how fast that galaxy was moving away from us at the moment the star died. It was the ultimate experiment, a meticulous, decades-long project designed to map the deceleration of the universe, to finally measure the breaking power of cosmic gravity and determine whether our distant descendants would face the crushing heat of a collapsed universe or the freezing isolation of an infinitely large one. The researchers gathered the data. They plotted the light curves of the distant supernovas on their graphs. They ran the numbers through the supercomputers, cross-referencing the immense distances with the redshift velocities. They expected to see the expansion curve bending downward, indicating that the universe was losing its momentum. But when the results finally materialized on the screens, the data did not make sense. The distant galaxies were not where they were supposed to be. They were too far away. The light was too faint. The redshift was entirely wrong. The researchers checked their instruments. They checked for dust interference. They recalibrated the sensors and ran the mathematics again and again, trying to find the flaw in their calculations, because the numbers they were staring at violated the most fundamental assumption of modern physics. The stone thrown into the sky was not slowing down. The cosmic tug-of-war was a lie. The immense combined gravity of every star, every planet, and every black hole in the observable universe was completely failing to break the expansion. Instead of the expansion of space-time was dramatically speeding up. Imagine throwing that stone into the air, expecting it to fall. But halfway up, it suddenly ignites. It accelerates. It shoots upward into the atmosphere, defying the colossal mass of the Earth beneath it, tearing violently through the sky, propelled by a monstrous, invisible engine. The scientists had discovered a phantom energy, a repulsive pressure woven into the absolute zero of empty space, a force so pervasive, so impossibly vast, that it made up nearly 70% of the total energy budget of the entire cosmos. We called it dark energy, not because it is dark in color, but because we are completely blind to its true nature. It is not a localized force. It does not radiate from a source like light or gravity. It is a property of the vacuum itself. The void is not empty. The void has a cost. And the more the universe expands, the more empty space is created. The more space is created, the more dark energy exists to push the universe apart. It is a terrifying, compounding loop of cosmic inflation. The safe, predictable universe of human intuition died in that moment. We realized that gravity, the architect of our reality, the force that binds the galaxies and holds our feet to the ground, is losing the war. It is being utterly overwhelmed by an invisible tide that is stretching the very geometry of existence faster and faster and faster. To grasp the true, terrifying scale of what is happening to the fabric of reality, we must first abandon the way we visualize the universe. When you close your eyes and picture the cosmos, you likely imagine a vast, black ocean sprinkled evenly with shining islands of stars and galaxies. A uniform distribution of light. That image is entirely false. If you were to pull back far beyond the borders of our Milky Way, beyond the local group of galaxies, beyond the colossal Virgo supercluster, you would witness the true architecture of existence. At the largest observable scales, matter is not scattered randomly. It is woven into a staggering, labyrinthine structure known as the cosmic web. Imagine a three-dimensional spiderweb stretching across 93 billion light-years of space. The silk threads of this web are massive filaments made of dark matter and thousands of galaxies, strung together like glowing pearls on an invisible string. Where these immense filaments intersect, gravity has crushed millions of galaxies together into blindingly bright nodes. But the filaments and the nodes are not the most prominent features of the cosmic web. The true defining feature of our universe is the emptiness in between. Bounded by the glowing threads of galaxies are the cosmic voids. These are vast, desolate spheres of almost absolute nothingness, regions of space so unimaginably large that they defy human comprehension. Take, for example, the Boat's void. It is a spherical desert measuring nearly 330 million light-years in diameter. If our Milky Way galaxy were placed in the dead center of the Boat's void, we would not have even known that other galaxies existed until the 1960s. Our night sky would have been completely black beyond our own local stars. These voids are not merely empty space. They are the engine rooms of our doom. In the dense, crowded regions of the cosmic web, where galaxies cluster together, gravity is still strong enough to hold things in place. The gravitational pull of dark matter and stellar mass creates localized pockets of resistance. But inside the colossal voids, gravity is practically non-existent. There is no mass to anchor the fabric of space, and it is precisely here, in the darkest, emptiest stretches of the cosmos, that dark energy reigns supreme. Because dark energy is a property of space itself, it is most dominant where there is nothing else to compete with it. Inside the massive voids, the repulsive pressure of the vacuum is actively stretching the distance between the edges. The voids are expanding like inflating balloons, pushing the galactic filaments further and further apart. The entire cosmic web is being brutally pulled apart from the inside out by the very emptiness it contains. But how can we possibly know this? How do we measure the invisible mechanics of a vacuum stretching across billions of light-years? We do not simply guess, we use the most massive, precise measuring tool ever conceived by human intelligence. We use the fossilized echoes of the Big Bang itself. To understand this, we must travel back to the extreme infancy of reality. Just 380,000 years after the birth of the universe, there were no stars, there were no galaxies. The entire cosmos was an inconceivably hot, dense ocean of subatomic particles and blinding radiation. It was a primordial soup of plasma. Inside this superheated ocean, an epic battle was taking place. The immense gravity of the dark matter was trying to crush the particles together, while the intense heat and radiation were violently pushing them apart. This titanic struggle between gravity and radiation created physical sound waves, gigantic, spherical ripples of acoustic energy that traveled through the plasma of the early universe at more than half the speed of light. These were not sound waves you could hear. They were mechanical pressure waves, compressing and expanding the raw material of reality. Then, the universe expanded enough to cool down. The plasma rapidly transitioned into transparent gas. The radiation decoupled from the matter and escaped into the void. And in that exact mathematical instant, the sound waves froze. The spherical ripples of condensed matter were permanently locked into place. As the universe continued to expand over the next 14 billion years, these frozen acoustic spheres expanded with it. Today, the edges of these ancient sound waves form the very scaffolding of the cosmic web. Galaxies have a much higher statistical probability of forming along the edges of these immense, frozen spheres. Astrophysicists call these structures baryon acoustic oscillations, and they are the key to measuring the terror in the dark. Because we know the exact, precise physics of the early universe, we know exactly how large these sound waves were when they froze. Today, they measure roughly 490 million light-years across. They are a universal standard ruler, a physical yardstick stamped into the distribution of galaxies across the entire cosmos. To read this ruler, humanity built massive, dedicated machines. High in the cold, thin air of the Sacramento Mountains in New Mexico. At the Apache Point Observatory, a specialized telescope spent years executing the Sloan Digital Sky Survey. It was not capturing pretty pictures. It was ruthlessly, systematically mapping the exact three-dimensional coordinates of millions of distant galaxies. Engineers constructed massive aluminum plates, drilling thousands of microscopic holes into the metal. Each hole corresponded to the exact location of a specific galaxy in the night sky. Technicians manually plugged fiber optic cables into every single hole, connecting the light of thousands of individual galaxies to a highly sensitive spectrograph. Night after night, year after year, the telescope stared into the deep. The silicon detectors captured the ancient photons, splitting the light into its fundamental spectral lines. By analyzing the redshift of millions of galaxies, supercomputers were able to map the exact locations of the baryon acoustic oscillations across different eras of cosmic history. They measured the size of the cosmic ruler as it existed 2 billion years ago, then 5 billion years ago, then 10 billion years ago. The results from the Sloan Digital Sky Survey and the subsequent Dark Energy Survey provided a chilling, undeniable confirmation. The expansion of space was not a smooth, steady glide. The cosmic ruler was stretching at an accelerating rate. The mathematics proved that roughly 5 billion years ago, the universe shifted gears. The density of matter had spread out just enough that the inward pull of gravity was finally overwhelmed by the outward push of dark energy. That was the exact moment the cosmos lost its grip. That was the moment the acceleration began. But what is the source of this repulsive force? What exactly is dark energy? When astrophysicists and theoretical physicists slam headfirst into a mystery of this magnitude, they turn to the most successful, rigorously tested framework in the history of human science. Quantum field theory, quantum mechanics, dictates that a true, absolute vacuum is physically impossible. Empty space is not a void. It is a bubbling, chaotic ocean of quantum fields. Even if you were to take a box, remove every single atom, every single photon, and shield it from all external radiation, the inside of that box would still not be entirely empty. At the subatomic level, empty space is boiling. Virtual particles, pairs of matter and antimatter, are constantly, spontaneously popping into existence from the fundamental energy fields, only to instantaneously annihilate each other a fraction of a millisecond later. This is not science fiction. This is a proven, measurable phenomenon known as vacuum fluctuation. Because these virtual particles possess energy, and because Einstein proved that mass and energy are interchangeable. This means that the vacuum of empty space itself must have an inherent weight, a base level of energy woven into the fabric of the void. Physicists call this vacuum energy. It seemed like the perfect, elegant solution to the dark energy mystery. If empty space has an inherent energy, and that energy exerts a repulsive, outward pressure, then we have found the engine driving the acceleration of the universe. So, the theoretical physicists sat down with their chalkboards and their supercomputers. They calculated exactly how much vacuum energy should exist in empty space. Based on the rigid, proven laws of quantum mechanics, they factored in the energy of the electromagnetic field, the strong nuclear field, and the weak nuclear field. They added it all up to determine the total outward pressure of the void. When they derived the final number, they stared at a mathematical catastrophe. According to quantum mechanics, the vacuum energy should be incredibly, unimaginably powerful. In fact, it should be so powerful that the repulsive force of empty space should have instantly, violently torn the entire universe apart in the very first fraction of a second after the Big Bang. If the quantum calculations were correct, atoms could never have formed, stars could never have ignited. The fabric of space-time would have been instantly shredded by its own internal pressure. But we are here, the stars are shining, the universe exists. So, the astronomers looked at the actual, observational data. They calculated the exact amount of dark energy required to cause the specific, gentle acceleration we are currently measuring with our telescopes. The difference between the theoretical prediction of quantum mechanics and the actual, observed reality of the cosmos is known as the cosmological constant problem, and it is universally considered the single worst prediction in the history of physics. The quantum calculation was wrong, not by a small margin. It was wrong by a factor of 10 to the power of 120. That is a 1, followed by 120 zeros. It is a discrepancy so massive that the human brain cannot even begin to conceptualize the error. It is a mathematical chasm that proves a terrifying reality. We do not understand the fundamental physics of our own universe. There is a ghost in the machinery of reality. Something is suppressing the explosive power of the vacuum energy, keeping it just low enough to allow the universe to exist, but just strong enough to slowly, inexorably pull it apart. And while the theoretical physicists argue over broken equations in their laboratories, the observational astronomers are watching the physical consequences of this ghost playing out in real time through the lenses of the James Webb Space Telescope. They are watching the night sky die, because the expansion of space is not limited by the laws of physics that govern objects within space. Einstein's theory of special relativity dictates a hard, unbreakable speed limit for the universe. Nothing, no particle, no ship, no information, can travel through space faster than the speed of light. That is approximately 300,000 kilometers per second. It is the absolute maximum velocity of physical reality. But there is a terrifying loophole in Einstein's math. The speed limit only applies to objects moving through space. It does not apply to space itself. The fabric of space-time is completely free to stretch and expand at any speed it wants, entirely unconstrained by the speed of light. And because the universe is accelerating, the math leads to a dark, inevitable conclusion. The further away a galaxy is from us, the more expanding space exists between us and that galaxy. And because every single metric mile of that intervening space is stretching, the cumulative effect means that distant galaxies appear to be receding from us at incredibly high velocities. If you look far enough out into the deep void, you eventually reach a mathematical boundary, a specific distance where the cumulative expansion of space between us and the distant galaxies is happening faster than the speed of light. This boundary is known as the cosmic event horizon. It is not a physical wall. It is an optical threshold. If a galaxy is pushed beyond this horizon, it is moving away from us faster than its photons can travel back toward us. The light it emits will never, ever reach our telescopes. The space between us is simply stretching too fast for the light to cross the gap. It is like a desperate swimmer trying to swim against a raging river that is flowing backward faster than they can paddle. Right now, as you listen to these words, the cosmic event horizon is roughly 16 billion light-years away. But remember, the expansion is accelerating. The dark energy is multiplying its pressure. Because the universe is accelerating, that cosmic event horizon is not static. It is actively shrinking inward, drawing closer and closer to us. It is a black curtain falling across the grand stage of the cosmos, slowly swallowing the distant stars. Every single second of every single day, thousands of distant galaxies cross the horizon. They slip over the edge of observability. The photons they emitted millions of years ago will be the last visual evidence we ever receive of their existence. Once they cross that threshold, they are permanently severed from our reality. No signal, no matter how strong, can ever bridge the expanding void between us. We are being quarantined. The universe is actively segregating itself. If humanity, or whatever descendants we leave behind, were to survive for another 2 trillion years, they would look up at the night sky and see absolute, unbroken blackness. The accelerating expansion of dark energy will have pushed every single galaxy outside of our local group, beyond the cosmic event horizon. The cosmic web will be shattered. The magnificent clusters of light will be gone, replaced by an infinite, freezing void. Future astronomers will have no evidence that the wider universe ever existed. They will have no cosmic microwave background to measure. They will have no distant supernovas to track. They will look into the abyss, and the deep time isolation will make them believe that our tiny, lonely cluster of stars is the entirety of creation. The standard model of cosmology accepted this grim, lonely fate. The Big Chill. A slow, dark, fading into isolation, but a reality where at least the local structures, our galaxy, our solar system, our planet, would remain intact, bound by our localized gravity, surviving in the dark. But the newest data suggests that the standard model was far too optimistic. The assumption was that dark energy was a constant, a steady, unchanging pressure pushing only the largest scales of the cosmos. But what if it is not constant? What if the repulsive pressure of the vacuum is dynamic? What if the density of dark energy itself is increasing as time moves forward? If the phantom energy in the void is growing stronger, then it will not just push the distant galaxies away. It will eventually turn its attention to the local structures. The safe harbor of our own gravity will not hold. We are standing at the edge of a mathematical precipice. The data from our most advanced telescopes is whispering a new, horrifying possibility. A scenario where the acceleration does not stop at the edge of our galaxy. A scenario where the foundational geometry of the universe does not just stretch, but violently, relentlessly, completely shatters. How do astrophysicists mathematically define the end of the world? They do not use apocalyptic language or grand philosophical declarations. They use a single, unassuming letter of the alphabet, the letter W, in the cold, rigid language of cosmological thermodynamics. This letter represents the equation of state for dark energy. It is a simple, fundamental ratio, the ratio of the pressure exerted by dark energy to its total energy density. This single, invisible number dictates the ultimate fate of physical reality. To understand the terrifying barrier that modern physics has currently crashed into, we must dissect the mechanics of this equation. For decades, the standard model of cosmology desperately needed the parameter W2 equal exactly -1. If the ratio is perfectly -1, it means that dark energy behaves as a cosmological constant. It means that as the universe expands, and as billions of light-years of new, empty space are created, the absolute density of the dark energy remains exactly the same. The void does not get weaker, but it also does not get stronger. The pressure remains steady, constantly and quietly pushing the distant galaxies away. If the parameter is exactly -1, we face the big chill, the slow, dark fading into isolation that we previously discussed. It is a lonely fate, but a stable one. The fundamental forces of nature would survive, but measuring the exact, pristine value of this parameter across billions of light-years of expanding space is a mathematical nightmare. And over the last decade, our most precise observational tools have begun to detect a severe, catastrophic crack in the cosmological constant. We are currently living through the greatest crisis in the history of modern astrophysics. It is a massive theoretical deadlock known as the Hubble tension. The tension arises because we have two completely different methods for measuring the current expansion rate of the universe, and the results are actively destroying each other. The first method is looking at the distant past. The European Space Agency deployed the Planck Space Observatory to orbit the Sun, trailing perfectly behind the Earth. Its mission was to map the cosmic microwave background, the residual heat left over from the Big Bang, by meticulously measuring the microscopic temperature fluctuations in this ancient radiation. Physicists were able to look at the exact density of the universe when it was only 380,000 years old. By feeding this pristine, early universe data into our standard model of physics, they could predict exactly how fast the universe should be expanding today. The supercomputers processed the ancient light and delivered a very precise prediction. The universe should be expanding at a rate of 67.4 kilometers per second per megaparsec. The second method for measuring the expansion rate is looking at the local, modern universe. We use the Hubble Space Telescope and the James Webb Space Telescope to look at Cepheid variable stars in our neighboring galaxies. These are massive, unstable stars that physically pulsate, swelling, and shrinking in a predictable rhythm. Because the timing of their pulse is directly linked to their true, mathematical brightness, we can use them as perfect distance markers. We measure exactly how far away these local galaxies are, and we measure exactly how fast they are moving away from us. When astronomers calculate the expansion rate using this modern, local data, the number is fundamentally different. It is 73.2 kilometers per second per megaparsec. For years, the scientific community assumed this discrepancy was just a simple human error, a smudge on a lens, a failure in calibration, a slight miscalculation in the cosmic distance ladder. But as the instruments became sharper and the data pools became massive, the error margins shrank into oblivion. The European Space Agency checked their data 1,000 times. The local supernova teams checked theirs. Both measurements are absolutely, undeniably correct. The gap between 67 and 73 is no longer an error. It is an insurmountable physical barrier. The discrepancy has now reached a statistical significance of 5.0 sigma. In the strict realm of particle physics and cosmology, a 5 sigma rating means there is only a 1 in 3.5 million chance that this difference is a statistical fluke. The tension is real. The machinery of reality is broken. The universe is expanding significantly faster right now than the rigid laws of physics dictate it should be. Something unknown, something entirely absent from our standard models, has injected a massive amount of excess energy into the void over the last few billion years. And this is where the theoretical physicists are forced to confront the abyss. This is where they must look at the parameter W and ask the question that terrifies them. What if the equation of state for dark energy is not exactly -1? What if the observational data is proving that the parameter has dropped below that mathematical floor? What if the true value of W is -1.05 or -1.1? If the ratio of pressure to density drops below -1, the fundamental laws of thermodynamics are turned upside down. It introduces a concept so mathematically violent that many physicists initially refused to publish papers on it, hoping it was merely a theoretical artifact. They call it phantom dark energy. To understand why phantom energy is so destructive, you have to understand the strong energy condition of general relativity. In normal, rational physics, as a physical volume expands, the density of the matter, or energy, inside that volume must decrease. If you have a sealed glass box filled with pressurized gas, and you suddenly expand the size of the box, the gas molecules spread out, the density drops, the internal pressure weakens. Even with a standard cosmological constant, the density remains neutral. It simply stays the same while the volume grows. But phantom dark energy entirely breaks the strong energy condition. If the parameter is less than -1, it means that, as the volume of space expands, the density of the dark energy actively increases. The larger the void becomes, the heavier the vacuum gets. It creates a catastrophic, infinite feedback loop. The phantom energy pushes space outward, creating more space. Because there is more space, the density of the phantom energy multiplies. Because the density multiplies, the repulsive pressure becomes stronger, pushing the space outward even faster, creating even more space. The repulsive pressure of the vacuum does not just quietly accelerate the distant galaxies. It rises like an invisible floodwater, compounding upon itself, doubling and redoubling its strength. If phantom dark energy is the true engine behind the Hubble tension, then we are not drifting toward the big chill. We are actively accelerating toward the big rip, a strict, calculable deadline where the phantom energy will achieve infinite density, completely overpowering every fundamental force holding matter together. Currently, the ambient pressure of dark energy is incredibly weak on a localized scale. The gravitational tether of our Sun is vastly, overwhelmingly stronger than the repulsive push of the vacuum within the borders of our solar system. The outward push of space is happening all around us, even in the room you are sitting in. But the chemical bonds in your body and the gravity of the Earth simply hold you together, entirely ignoring the microscopic tug of the void. But the terrifying nature of phantom energy is that its density is actively rising over time. The pressure is building. The water behind the dam is climbing higher. Theoretical physicists at Dartmouth College have mapped out the exact mathematical timeline of the Big Rip scenario. They calculated the precise chronological breakdown of physical reality. Assuming a phantom energy parameter of -1.5, it is a roadmap of our destruction, driven by the inescapable escalation of the vacuum. According to their calculations, if the universe has roughly 22 billion years left to exist, the massive galactic structures will be the first to fall, roughly 60 million years before the end of time. The phantom energy density will rise high enough to overpower the collective gravity of the Milky Way. Imagine standing on a dark planet near the edge of our galaxy. For billions of years, the supermassive black hole at the center of the Milky Way, combined with the immense scaffolding of dark matter, has held the spiral arms together in a beautiful, rotating disk. But as the vacuum pressure surges, that gravitational tether begins to stretch, and then it snaps. The outer stars of the Milky Way will be violently peeled away, dragged out into the expanding abyss. The spiral arms will unravel like a spool of thread caught in a hurricane. The stars will not be destroyed yet, but they will be isolated, pushed away from their neighbors at speeds exceeding the escape velocity of the galaxy. The magnificent, swirling structure of the Milky Way will simply dissolve into a chaotic diaspora of lonely suns. But the phantom energy does not stop there. The feedback loop continues. The density of the vacuum keeps climbing. 3 months before the end of time, the pressure of empty space will breach the borders of our solar system. The intricate, clockwork orbits of the planets are maintained by a delicate balance. The forward velocity of the planets is perfectly countered by the immense gravitational pull of the Sun. But as the phantom energy density spikes, it introduces a massive, outward pushing wedge into that balance. The vacuum itself begins actively repelling the planets away from the star. The outermost gas giants, Neptune and Uranus, will be the first to lose their gravitational lock. Their orbits will rapidly widen, spiraling outward into the freezing dark. Shortly after, Jupiter and Saturn will be torn from their paths. And then, the Earth, the invisible cord of gravity connecting our planet to the Sun, will be severed. The Earth will be cast adrift into a pitch-black void, moving away from the fading light of our star. The night sky will be absolutely, perfectly empty. No Milky Way, no neighboring planets, just a terrifying, unbroken blackness. But even in this utter isolation, the planet itself would still be physically intact. The gravity of the Earth's core would still hold the rock, the oceans, and the atmosphere together. For a few more weeks, just 30 minutes before the absolute end of time, the density of the phantom dark energy will reach a critical threshold. The repulsive force of the vacuum will overpower the localized gravity of planets and moons. The Earth will not simply crack or crumble, it will explode. The outward pressure of space itself will become stronger than the gravitational force holding the tectonic plates and the molten mantle to the iron core. The planet will be violently shredded from the inside out, expanding into a massive, dispersed cloud of unattached rock and dust. At this point, gravity has been completely erased from the universe. The architect of the cosmos has been entirely defeated, but gravity is only the weakest of the four fundamental forces of nature. The true horror of the Big Rip lies in the final fractions of a second, where the phantom energy attacks the quantum foundations of matter itself. Just 10 to the power of -19 seconds before the end of the universe, the vacuum pressure will overpower electromagnetism. Electromagnetism is the force that holds molecules together. It is the force that binds electrons to the nucleus of an atom. It is the reason solid objects exist. It is the reason biology is possible. In a fraction of a millisecond, every chemical bond in the remaining debris of the universe will violently snap. The dispersed rocks of the shattered Earth will instantly dissolve into a cloud of solitary atoms. If there were any biological life forms somehow observing this event in armored spaceships, their vessels and their own bodies would instantly vaporize into a microscopic mist of unbonded elements. The flesh, the metal, the glass, all of it instantly losing the ability to hold its physical structure. And then, the final barrier, in the exact final mathematical instant of the universe's existence, the density of the phantom energy approaches infinity. The repulsive pressure becomes so absolute, so overwhelmingly violent, that it attacks the strong nuclear force. The strong nuclear force is the ultimate lock in physical reality. It is the immensely powerful binding energy that holds protons and neutrons together inside the microscopic nucleus of an atom. It takes the staggering power of a thermonuclear detonation or a particle accelerator to break this bond. The phantom vacuum will break it effortlessly. Every single atom in the entire cosmos will be simultaneously torn apart. The protons and neutrons will be ripped away from each other, and immediately after, the subatomic quarks that make up those protons will be shredded. The physical universe is reduced to an infinite ocean of disconnected, fundamental particles, screaming away from each other at unimaginable speeds. And then, the paradox arrives. Because the phantom energy feedback loop is infinite, the expansion does not stop when the atoms die. The mathematics dictate that the scale factor of the universe, the metric size of space itself, must reach infinity in a finite amount of time. The fabric of space-time is stretched beyond the Planck length. It is stretched beyond the capacity of mathematics to maintain continuity. In the final moment of the Big Rip, we encounter a physical singularity. When you hear the word singularity, you likely imagine the center of a black hole, a point of infinite density, where matter is crushed down into a microscopic dot, and space is infinitely compressed. The Big Rip is the exact opposite. It is a singularity of infinite expansion. The distance between any two theoretical points in space becomes instantly infinite. Time itself completely stops, because there is no longer any physical metric by which to measure the movement of matter or the transfer of energy. The geometry of reality simply ceases to function. Space loses all physical meaning. This is the grim consequence of the phantom energy model. This is the mathematical nightmare hiding behind the parameter W and the tension in the Hubble data. It is not just an end to the stars or the galaxies. It is the total, mechanical dismantling of the physical universe, leaving nothing behind but an infinitely expanding, timeless void where even the concept of distance has been violently erased. We are left staring at the raw data from our orbital telescopes, watching the distant supernovas fade, knowing that every new piece of evidence we gather only sharpens the blade of this impending reality. The barrier of our understanding is slowly giving way to a truth that our minds were never designed to endure. To comprehend the true severity of the phantom energy model, we must look past the violent destruction of planets and stars. The physical shredding of matter is a terrifying spectacle, but it is only a symptom. The true horror of the Big Rip lies much deeper. It is not merely the end of physical objects. It is the absolute destruction of causality, information, and the flow of time itself. In the strict, rigorous framework of quantum mechanics, there is a sacred, unbreakable law. It is the principle of the conservation of information. This principle states that the fundamental physical properties of the universe cannot be permanently erased. If you were to take a highly complex object, a human being, a computer server, or a written book, and burn it into ash, human intuition says the information is gone forever. But quantum mechanics says otherwise. If you had a supercomputer powerful enough to track the exact trajectory and quantum state of every single photon of light, every molecule of smoke, and every flake of ash emitted by that fire, you could, theoretically, run the mathematics backward. You could reconstruct the book. You could read the words. The universe always remembers what it used to be. The past is permanently encoded into the present. This chain of cause and effect, the ability for particles to interact, bounce off one another, and exchange energy, is the foundation of reality. We call it causality. But the phantom dark energy completely shatters this foundation. Remember the cosmic event horizon, the boundary where the expansion of space exceeds the speed of light. Currently, that boundary is billions of light years away. But in the final stages of the Big Rip scenario, as the density of the vacuum surges toward infinity, that horizon accelerates inward at a catastrophic pace. It does not just swallow distant galaxies, it swallows local star clusters. Then, it swallows neighboring planets. In the final fractions of a second, the horizon shrinks so violently that it becomes smaller than a single atom. This means that the expanding space between the nucleus of an atom and its own electrons is growing faster than the speed of light. When this happens, causality dies. The fundamental particles that make up the universe are suddenly, violently pushed beyond each other's event horizons. An electron can no longer send a photon to a proton. A quark can no longer interact with another quark. Every single subatomic particle in the entire cosmos becomes completely isolated in its own microscopic, infinitely expanding pocket of space. Imagine standing in a massive, brightly lit cathedral. Suddenly, the lights at the far end go out. A wall of absolute, impenetrable darkness begins marching toward you. The walls disappear into the black, then the pillars, then the floor just 10 feet away. Eventually, the darkness touches your skin, and you cannot even see your own hands. That is what happens to the fundamental building blocks of reality. They are blinded. They are severed from the rest of existence. And because no particle can ever communicate with another particle ever again, the conservation of information is permanently broken. The universe forgets what it was. The ashes can never be reconstructed into the book because the ashes no longer exist in the same observable reality. The concept of history is entirely erased from the cosmos. This total isolation triggers an even more profound collapse. The death of time. What is time? To the human mind, time is the ticking of a clock. It is the rising and setting of the sun. But to an astrophysicist, time is not a mechanical device. Time is a measurement of entropy. Entropy is the second law of thermodynamics. It is the strict physical rule that the universe must always move from a state of order to a state of disorder. a glass of water falls off a table and shatters into 100 pieces. The pieces will never spontaneously reassemble themselves and jump back onto the table. A hot cup of coffee will always cool down, transferring its heat into the surrounding air. The air will never spontaneously gather its heat and push it back into the cup. This one-way street, this irreversible progression from concentrated energy to dispersed chaos, is what gives the universe an arrow of time. We experience time moving forward purely because entropy is increasing. But for entropy to increase, things must be able to interact. Heat must flow from one object to another. Molecules must collide. Stars must burn their fuel and radiate light into the dark. In the immediate aftermath of the Big Rip, all interactions cease, because every single elementary particle is permanently trapped in its own isolated, expanding bubble. Nothing can touch. Nothing can collide. Heat cannot flow, because there is no neighboring particle to absorb the heat. The entire cosmic machinery comes to an absolute grinding halt. A clock can only tell time if its gears are allowed to turn. When the universe is ripped down to solitary, disconnected particles, there are no more gears. Entropy flatlines. It reaches a state of absolute, mathematical, zero change. And when entropy stops, time stops. The universe does not simply go dark. It enters a state of frozen, timeless suspension. A permanent, unchanging photograph of an infinitely expanding nothingness. Millions, billions, and trillions of years lose all physical meaning, because a trillion years in a universe with no events is exactly identical to a single second. It is a reality completely devoid of consequence. This forces us to confront a deeply unsettling philosophical reality, a reality that strikes at the very core of human psychology. Everything that humanity has ever achieved and everything we will ever build is predicated on a specific, unspoken assumption. We operate under the implicit belief in a permanent universe. We build massive monuments out of stone and steel. We compose symphonies. We archive our knowledge on digital servers and bury it deep inside mountains. We write down our histories. We do all of this because we possess an inherent biological need to leave a legacy. We desperately want to believe that even after we are gone, even if our entire species goes extinct, the things we created will physically remain. We assume that the Earth will still orbit the Sun, and that the physical evidence of our existence will quietly endure in the dark, waiting for someone or something to find it. The phantom energy model violates this fundamental psychological contract. It tells us that there is no safe harbor in the deep future. There is no silent, cold museum of human history. The acceleration of the void guarantees absolute erasure. It will not just destroy the monuments we built. It will destroy the tectonic plates they were built upon. It will destroy the iron core of the planet that held them down. It will destroy the microscopic carbon atoms that made up the hands of the people who carved the stone. Every single physical trace that humanity or any other advanced civilization in the cosmos ever existed will be violently dismantled and pushed beyond the boundary of observability. The cosmic web, the billions of galaxies, the grand, swirling nebulae where stars are born. All of it is temporary. We are living inside a fleeting, transient window of cosmic stability, a brief, quiet era where the density of matter and the pressure of the vacuum are engaged in a delicate, temporary standoff. But the math indicates that the standoff is failing. The scale is tipping. The universe is actively turning hostile toward the concept of structure. The very geometry of space is becoming an existential threat to the matter that resides within it. We are currently the only known species in the universe capable of measuring the cosmological constant. We have built the orbital mirrors. We have mapped the distant supernovas. We have calculated the redshift of the ancient light. We have looked deeply into the mechanics of our own execution. We are forced to sit in the quiet of our observatories, staring at the raw data on the monitors, fully aware of the phantom force that is multiplying in the empty spaces between the stars. We are measuring the exact speed at which the darkness is closing in, and yet, knowing the exact mathematical parameters of the abyss does not give us any power to stop it. We are merely passengers on a structure that is structurally unsound, moving toward a breaking point that we can calculate but never prevent. The physical laws of thermodynamics and quantum mechanics are entirely indifferent to our existence. They do not care about our history, our legacy, or our profound terror of the void. They are simply executing a cold, irreversible equation. The energy must expand, the space must stretch, the fabric must tear. As the tension in the Hubble data grows, and the discrepancy in our measurements becomes an undeniable wall of evidence, we are left staring at the most horrifying reality modern science has ever uncovered. The universe is not a cradle. It is a machine, and like all machines, it is subject to the fundamental laws of failure. For thousands of years, humanity looked up at the stars and projected our own desperate desire for permanence onto the cold vacuum. We imagined a cosmos that was carefully balanced, a grand eternal architecture that would safely preserve the light of the stars for all of time. But the mathematics of phantom dark energy reveal a much colder, much more violent truth. The foundational geometry of space-time is entirely indifferent to the matter it contains. The expanding void does not know we are here. It does not recognize the complexity of a living cell, the immense gravitational beauty of a spiraling galaxy, or the fragile structures we have built on this microscopic planet. The void will not pause its exponential acceleration to spare the chemical bonds in our bodies. The physical universe is engaged in an act of absolute, unstoppable self-destruction. We are standing on a microscopic grain of silicate rock, floating in the middle of a temporary cosmic anomaly. The very fact that we possess the consciousness to observe this phenomenon, that we have the brief, fleeting opportunity to look through our glass lenses and measure the exact rate at which the darkness is tearing the fabric of reality apart, is nothing more than a cruel mathematical coincidence. We are a brief, dying spark, suspended in an infinite, rising ocean of phantom energy. Humanity has spent its entire history trying to understand the deeper meaning of the cosmos, constantly searching for a grand design, a final purpose, or a sense of localized importance. We write our histories, assuming someone will eventually read them. But the absolute final state of physical reality is not a grand, unified structure. The final state is complete, inescapable isolation. It is a reality where every single fundamental particle is permanently severed from every other particle by a wall of expanding space. It is an infinite, timeless silence where nothing can ever be built, nothing can ever be destroyed, and nothing can ever be remembered. The concept of history itself will be physically erased from the void. When you look up at the night sky, do not let your biological intuition lie to you anymore. Do not see a static, peaceful dome of stars. See the unseen tension. Look at the immense, black spaces between those points of light, and understand that those exact empty spaces are actively, violently, pushing outward. The distance is compounding. The physical pressure of nothingness is multiplying. The void is already winning the war. We are merely passengers living in the final, decaying stages of the most beautiful, structured era the universe will ever experience, and it is actively dissolving around us. The cosmic clock is ticking, not toward a new rebirth, but toward a total mechanical failure of space-time. There is no escape from the mathematics of the expansion. There is no engineering that can brace against the repulsive pressure of the vacuum. The phantom energy will eventually hunt down every star, every wandering planet, and every solitary atom. The darkness is not just waiting for us, it is accelerating toward us. And when the final fundamental force is broken, the cosmos will finally achieve its ultimate, eternal state. Perfect, unbroken, infinite emptiness.